Welcome back, everyone. And here is another lesson in physics. And for this lesson, we are going to talk about how we measure time in physics. So these are the learning objectives. We'll be specifically looking at how to measure time accurately using a stopwatch. And then we're going to look at a device or a tool that is normally associated to time, which is the pendulum. Now, when you are doing physics in the lab, and especially for your O-level syllabus, the number one instrument that you will use in order to measure time are these things here. These are called stopwatches. Now, very important for you to be able to read a digital stopwatch properly. The number at the very front is the number for the minute. The number in the middle of the stopwatch gives you the time in second, and the number at the very end here gives you the millisecond or the 100th of a second. So in this case here, what is the reading on this watch? So this is 0 minutes, as you can see, 19 seconds, 0.98 seconds. So this is how you read this particular stopwatch. Let's do some other examples. The stopwatch on the left, this is the minute. So you have 10 minutes, and this gives you the second, 51 second, and this gives you the millisecond, so 51.46 seconds. So sometimes when you are doing your measurements in time, you have to convert everything into one unit. So usually you will be asked to convert it to seconds. So you convert everything to seconds. 10 minutes, you convert to second. You know that 1 minute is equal to 60 seconds. So if you have 10 minutes, that will be equal to 600 seconds. And then you plus that with 51.46 seconds, and 10 minutes, 51.46 seconds is exactly 651.46 seconds. Okay. Now, what about this stopwatch here? The minute number is 0, so this is 0 minutes. Sometimes you don't even have to write if it's 0, and the second is 37 seconds, point seconds. So for this stopwatch here is 37.22 seconds. Some more things you need to know when you are measuring time in physics. When it comes to the digital stopwatch, the smallest scale for a digital stopwatch is 0.01 second. Therefore, when you are making readings, it has to be recorded to the same decimal place as the smallest possible reading. Now, because the smallest possible reading is accurate up to 2 decimal place, therefore, when you record your reading, all of them have to be in 2 decimal places as well. For example, 22.41, so 2 decimal place there. If you have a time that is exact, then you should still follow this rule. Let's say you measured a time of something to be 12 seconds, then you should also include 2 decimal place values, which is 12.00 seconds. Now, here are some examples of wrong readings. This is a wrong reading because it's only to 1 decimal place. This is also a wrong reading because you are giving 3 decimal places. This is a wrong reading because you are not including the 2 decimal place. So an electronic stopwatch is more accurate than a normal clock because it can record to 2 decimal places. That means it can record down to 1 millisecond. So the 1 millisecond is equivalent to 0.01 seconds, while a clock can only measure up until 1 second. Now, one thing you have to be careful of when you are using a stopwatch is something that's called a reaction time. So that means when you are looking at something and when you are trying to start or stop the stopwatch, there is what we say a lagging time between you seeing the object starting and you pressing the stopwatch. So the time it takes for you to start the stopwatch while you are reacting to the object is what we call the reaction time. So in other words, sometimes you are pressing the stopwatch too fast. Maybe you're a bit nervous or maybe you're a bit fidgety. So you stop the time or start the time too early. That is also what we call a reaction time error. Or sometimes you stop the watch or you start the watch slow. That is also a reaction time error. Okay, so that's a normal error that students normally do or humans normally do when they are trying to measure time using a stopwatch. Next, I'm going to talk about an instrument or a tool that is normally associated with time in physics, and this is called the pendulum. So here I have an example of a pendulum. So a pendulum is basically a piece of string attached to a mass or something heavy, so that can be anything, and a pendulum swings back and forth. This motion of swinging back and forth, forwards and backwards, or left to right, side to side, this is what we call an oscillation, or in other words, the pendulum is oscillating. So this is an example of a pendulum. An example of one complete swing or one complete oscillation is when the bob moves through A, B, C, B, A. So this heavy thing that you attach to the string for the pendulum is what we call a bob. And one oscillation or one swing of the pendulum is from, if you start from A to B to C and then back to B and then back to A. So that is what we considered one oscillation. So using this as an example again, if you start the pendulum from here, so the pendulum has to go away and then back for it to consider as one oscillation or one full spring. Okay, so let me just, and then you let go. 1, 2, 3, 4, 5, and so on. So every time it returns back to its original position, then that counts as one oscillation. Okay, if you start on this side, so that means every time it goes back here, it's one oscillation. So let's say start here, 1, 2, 3, and so on. Now I'm going to show you the wrong way to measure the oscillation of a pendulum. So this is the wrong way. I'm going to play and start now. 1, 2, 3, 4, 5, 6, 7, 8. So this is the wrong way. Okay. So you have to see that the pendulum has to go away and then back again for it to count as one oscillation. So that's the correct way. The second thing that you need to know about the pendulum has a thing called a period. So a period is the time it takes for the pendulum to make one complete swing or one complete oscillation. So let's do this. Let's use this as an example again. Let's say we start from here. Okay, and then I'm going to press play. And I'm going to press pause. Now, the pendulum took about 3 seconds, all right, 3 to 2 seconds for it to have one complete swing. That 3 second is called the period of the pendulum. Okay, so in this case, the pendulum has a period of 3 seconds. If the period is longer, let's say in this case, that takes about like 5 seconds. So the period is 5 seconds. So the period is the time it takes for the pendulum to complete one oscillation or to complete one full swing. You try to find the period of the pendulum. So the experiment will be set up something like this, and you have to make the pendulum oscillate a couple of times in order for you to measure the period. So these are the steps to this practical. For now, you can just briefly look through it. We will cover this in the future in the lab. Right, so that's the end of this lesson. So to briefly summarize what we went through, in physics, we normally use the stopwatch to measure time. So especially when you are studying O-level, make sure you know how to read the stopwatch. So this digit here at the front, at the very front, is the digit for the minutes. This one is for the second, and this one is for the millisecond. So in this case, this is 19.98 seconds. When you are writing down your measurement for time, you have to write it down to 2 decimal places. So for example, 1.77. Okay, there should be 2 decimal places when you are writing down your reading for time. And then we looked at the pendulum. So pendulum is basically a swinging object. There is a string attached to a mass called a bob, and the pendulum oscillates back and forth. One full oscillation is from A to B, C, and then to B, and then back to A again. So that's one full oscillation. And then make sure you know what we mean by the period of a pendulum. The period is the time it takes for the pendulum to do a full swing or to do a full oscillation. So the next part of this lesson, we're going to talk about how volume is measured in physics.